Yeah, so now we're gonna complete the last part of the problem, and it is to determine the Q point or calculate the Q point of this MOSFET, this NMOS MOSFET, when the voltage GG is 4 volts. The first thing that we do is analyze if the voltage, if the MOSFET is in operation. And how do we determine that? We determine that by seeing if this equation is true. That the voltage from gate to source, the voltage from gate to source is greater than the voltage from the threshold voltage. The voltage from drain to source, knowing that this is 4 volts, we also know that no current will flow. So if no current flows through the gate of the MOSFET, the voltage at the gate is equal to VGG, which is 4 volts. And we know that the voltage at Vs is 0 because it's ground. So VGS equals VG minus Vs, which is, 4 minus 0, which is 4 volts. And 4 volts is greater than 2 volts because we have said that the threshold is 2 volts. So yes, we understand that the MOSFET is in operation. Now we will try to resolve this using the saturation equation. Notice that we have the voltage from gate to source, the threshold voltage, we have the length, we have the width, we have the parameter, the process transconductance parameter. So all we have to do is substitute and solve for I. The current that's going to be flowing through the drain is going to be 1/2 micro. This was 100 micros. This was 10 micros. And this is BGS, which we determined that was 4, minus 2. If we use our calculator to determine that value, we have that it's 10 milliamps. Okay, to determine if this current is correct, what we do is we see if this equation, or if this equation stands, that the voltage from drain to source is greater than the voltage from gate to source minus the threshold voltage. To find the voltage from drain to source, we have the voltage here from the drain voltage, and we have here the source voltage. So there's a fall voltage drop here. The current is coming down in this direction. So this is plus, this is minus. And it's coming down in this direction. So this is plus and this is minus. So we could do a KBL saying that BDD minus 1K times the current minus the voltage drop in the MOSFET equals 0. And then we solve for VDS for the voltage drop in the MOSFET. And we know all these. We know that the voltage VDD is 6 volts, 1010 milli. So this will result in negative 4 volts. Okay, so now we test if VDS is greater than VGS minus VT. This is minus 4 volts. VG was 4 volts minus 2 volts. We have minus 4 volts. This is not true. Negative 4 volts is not greater than 2 volts. So we conclude that the MOSFET is not in saturation. It is not in saturation. So we have to solve again everything, but this time using the triode equation to find the current. And this is a kind of long process, and it takes a couple of minutes. So that's the reason that we start with the saturation formula, because the triode formula it's a bit more time consuming to get to the result. So what we're gonna do is that we're gonna continue in the next video.